Hi, this is Dr. Siddhaling. I am expert in data science and machine learning. Today we are going to see how do we build convolution neural network for sentiment image analysis. So this is one of the practical applications where we can analyze the sentiment of the images, and this could be used for the market research and other similar type of applications. So let's go ahead and start understanding this concept. The sentiment image analysis. This is a website that is given by columbia.edu, and this particular work on focuses on the sentiment image analysis. They have given the paper also. You can take a look at this particular paper and the data set for both the text as well as images. So basically, they have collected 603 tweets with the photos, and that is intended to evaluate the performance of sentiment prediction. So this particular data set includes both the text as well as the images. So you can use it only to perform the text-based sentiment analysis or image, or with both together, like a text and images. And there are different hashtags which are used to collect these tweets are also shown over here, and how they have collected the ground truth and making the data set ready. There are 407 positive this one tweets, and then there are 133 negative tweets in this particular data set. Now you can obtain this data set by clicking on to here. So once you click it, the data set the opens in the Dropbox. There are five partition one, two, three, four, five, and this is very much suitable for performing the cross validation. So you can set one of the first partition for testing, remaining one to four you can utilize it for the training the convolution neural network, and repeat this procedure in order to perform the complete cross validation. And they also given the paper reference. Now you can click the paper reference over here. They have given mention the paper, so I have already clicked, and this is the paper. So describing about the sentiment analysis of social media data, and they have described how they have collected initially the data. So this is the way in which the data set they have prepared. Various aspects related to the adjective noun pair, and how they built the complete data set, Bank. All the details have been given to here, and various range of sentiments also they have discussed in this particular paper, along with the psychological foundation framework, and then they went for performing the sentiment analysis, and along with the adjective noun pair, and then they have discussed about the Centibank, and then followed by the recognition result coverage, and then followed by, so you can go through this particular, and then they have also given the sentiment prediction result at the end over here. So a similar kind of work we are going to utilize the Twitter data. So the I have downloaded this Twitter data, and this consists around 603 images. Instead of that, I have a small version of the data set consisting of samples, something like this. Each data set uh, partition has several images. Okay, these are the several images, and these images, there are ground truth associated with each one of the image. So you can see the first image is saying to be positive, seventh one is positive, sixth one is negative, and these labels are identified by the experts or the trucker that is associated in order to get the labels over here. Now we will utilize this data set and build our own convolution neural network. Let's jump in with the Python coding and understand how do we build this particular convolution neural network to perform the sentiment image analysis. Now I have used the various module in this particular task, writing the code, such as NumPy, OS, scalar image is a one that I am going to use it to manipulate with the images, such as performing the reading of the image, resizing, and then followed by grayscale to RGB conversion. And the PD, the pandas, is the one I'm going to utilize to read the ground truth values of the images and create the data frame. And of course we are going to use the keras and then the sequential model and then the convolution neural layer, and then followed by the various other layers such as max pooling, average pooling, dense, activation, and flatten. And the optimization is done with the help of HAD optimizing. Now, one of the ways to access the particular folder is to change the current directory. So wherever it is the dataset is located, we can go that particular location with the help of CHDIR. So the CHDIR is a method that is present in the OS module. Now, each one of these image having a different size. So let me go and check these sizes. So suppose if you just put the cursor on this one, this particular image is 612. There are other images having a different size, 150 by 150. So these are all having a different sizes. Now we can change this particular into a standard size. That dimension is initially defined in this particular tuple here. So 256 by 256. And the image size, we will also discuss about this one because we convert into the 3D, consisting of all the color information. So we'll go for a three dimension over here. And the number of classes, because there are only positive and the negative class, we will make it as a number of classes as 2. And batch size is designated as 10. So after 10 batch size, the training or the weights are going to be updated in the neural network. So I have set a very limited number of epochs so that it will finish the execution very fast. And then followed by the Twitter folder. So this is the Twitter folder where it is the dataset is located. And we will initially change. Let me keep on executing each one of these sentences, and then we will also understand how what are the values that are retained in each one of these variables. Number of classes is 2, batch size is 10, number of epochs is 2, and this will be pointing to the location where the data set is present. Now, as you know, there are 5 different folders, 5 different partitions that are present in the. So if I just display this directory, so this is what the content, like ground truth, that is also part of the directory, and then there are 5 different partitions. And later we will also need to read the CSV file, the text file that is comma separated, and create the, yeah, so create the entire sentence has to be executed. So they create the data frame. So the data frame will look like here. uh, so so this is the data frame. So let me open that. So class label, so you can see this particular each image starting with the index 1 image is positive, second image is positive, and so on. So with the help of indexing, I can locate the particular image number, and then I can also fetch its corresponding class. So this is how we create the ground truth into the data frame. So this is how we have created the data frame, and we will collect all the images along with their along with their paths. So the subdirectory dir will consist of all these images along with the paths that are present in our data set. So if I execute this, so this is a Twitter partition 1, 2, 3, 4. These paths are subdirectories which are present in the main directory of the image path. Now, because it itself consists of 5 different partition, we will select the first 4, 1, 2, 3, 4, for training the model, our model, and the last one, partition 5, for testing our model. So how do we need to create this, build up this one data set? That is the main critical issue when you want to build the convolution neural network and then train on these images. So one of the ways is to collect all these paths and create a training images of training paths itself. So this is how I have built. Now this will constitute all the images of the training with the path. So you can see if I type it over here and on the display, what are the different paths that are present. Now Twitter partition to 158, this is a path that is belonging to the Twitter data. In a similar way, I will also create the extracting only paths corresponding to each image that are present in our test. So this is a test and that is the train. And there are two major important functions which are required. One is form the image set. So let me execute and create the definition of the method and then prepare the data set. Okay, we'll come back to explanation of these two. Now I will also create this definition and the function is method is ready for the use. Okay, so let me also create the third method and keep it ready for the use. So all these definition are created now, and the first most job of our convolution neural network building is to prepare the data set. So that's the most important part of it. So we'll start preparing. So let me explain what we are exactly doing it. Anyway, we have divided the data set into first four are considered as a training and the last one is considered as the testing data set. So prepared data set is a method that I have created over here. So this is the prepared data set. Basically, it calls the form image set. So this will create the image set on the set of paths. So I have extracted all the paths and that are kept and that will be supplied to form image set. So this is the function. So here you can see this is a function in which all the paths corresponding to trainings are went over here. So with the help of a single path, I am able to extract and read the image. That is the concept. So I have all the paths related to training set and that all the paths are supplied over here and I can use the image read in order to read a single uh, image using the that particular path. So that is the main idea and I can do this one in a repeated way and two important aspect. One is the image set, that is the input that what we are giving it to convolution neural network, so that we are trying to build over here, and then followed by what is the expected target outcome, so either positive or negative, so that is also be built along in the form image method. Now, initially, we will make the image X image set as a empty and taking the same length as the number of paths or the number of images which are present over here. And dimension is set what we were expecting it to change the dimension of the image and make it as standardized. So that dimension is created, an image empty. And then another empty set is created for storing the target class, and this for loop iterates through each one of the path that are present in the all image folder path. So that is being actually the training path, and it will read a single image using the im read method that is given by a scalar image, and then it will split the path. So basically if I type it and show it what exactly the path itself consists of, so let me display all these paths from the training, and then it is very understandable. So it is basically a string separated by the forward slash over here, and then followed by a number. So this number can be extracted by splitting this entire string with the help of slash, and that's what we have done over here, and then followed by splitting with the dot because there is a dot present after dot jpg, and we will take out the particular number. So this particular number can be used and locate that number in the class label data frame and get the actual class. So this is what been done in these two steps. So if I show that how the data frame itself, say suppose I get the index 1, I can locate with the help of loc in the data frame and then collect the corresponding class label for the image 1. So this is the idea over here. So I can uh, collect the class label like positive. If it is a positive, I made it as 1, and if it is a negative, otherwise it is considered as 0. So there are only two classes in this particular, And some images may have additional information that is removed with the help of taking the extracting only three-dimension information with the help of these if statements. And then we will convert the image to, from, if there are any image maybe having only grayscale, they are all converted into RGB with the additional color information. And we will resize all of the images to a standard with a standard like 256 by 256. That is a standard size of the image that is being set over here. And after performing these processing, the each image is assigned to the IM image set. So this is repeated with the help of a for loop for going through all the images in that particular this training set. So this is a training set consists of various paths, and the for loop follows this particular steps for each one of the image. And at the end of that, we have a x, that is input, what input it should take the convolution neural network, that is ready, and that it will be sent to the prepare data set. So this is the prepare data set that receives x training set along with the y. So y is the target, because target is also created using the for loop by looking at the sentiment information that is present in the class actual class values. And once we have both these x image set as well as y set itself, we can process further on. Same thing is repeated on the test images also. Basically the test images are fewer than the overall train images, so we have few number of test images over here. And once we have a x image consisting of all the samples over here, so it is I can show here how it would look like. So it is basically x image train set. So this is of size 42, and each dimension of the image is 256 by 256 into 3. 3 is because it is consisting of also RGB information. And this all these images are now converted into float data type, and then followed by normalized to the range of 0 to 1. When we have the grayscale as well as RGB information, the color information, that range is between 0 to 255. And when we divide it each pixel by 255, then the range of values for each pixel will be between 0 to 1. So that's exactly taking place in these two steps. And then we will convert the type of the class from the number 0 1, because we have only 0 1, to categorical, making it as a binary. So it will be 0 1 1 0. So those kind of representation is carried out with the help of categorical. So this is the categorical method that is given by keras utils. And we can also display what is the size of these training and test data set. Once this much is ready, we are good to go and create our convolution neural network, and then supply these details like the input image as well as the what is expected target outcome, and then go for the training of that. So there is a one more method I have to create the uh, convolution neural network. So initially I have taken the sequential model, assigned it to model variable, and added the several convolution layers. The first convolution is very important to understand. First one is a two-dimensional convolution layer that is added with a 16 number of filters. The kernel size of each filter goes 11 by 11. Padding is the same, and this particular kernel is initialized with a Glerit uniform initialization procedure, and the bias initialized with the zeros. And the input shape is very important. This is exactly same of when you take a one particular, say for example, this will be represented 256 by 256 into 3. So that much information has to be supplied as a input shape. Once that is done, we can have a different combination depending on what type of optimization, the complexity of input samples, and then create the complete convolution neural network. Now, in this particular convolution neural network, I have added the activation as ReLU, then followed by max polling. So the combination of the ReLU as and well as max polling are required to improve the generalization capability, especially when we are working with the image data set. And this procedure is repeated by adding the more number of convolution layer, like second one over here, with a slight change in the number of kernels and the size of the kernel. And 192, that is the third layer, and the fourth layer with 192, and each one is initialized with the same type of initialization procedure, that is gluroot uniform. And then followed by there are seven such layers. They have we have created over here. This is a convolution 2D that has been added. And at the next step is to flatten this, because the convolution layer we have to create the flatten and then go for a dense neural network in order to perform the final classification. So the feature extraction procedure will be carried out by seven number of different convolution layers, and the flattening layer is also added over here. And the dense also takes the number of classes. In this case we have two number of classes prediction, and again the kernel is initialized with the help of gluroot uniform procedure. And then at the last we also have a activation function of softmax. So this will create the overall model. Once the model is created, we can start compiling that. So this is the create. So let me execute this one. So this is the create module. So this basically calls the create a model method over here, and this will, the entire convolution neural network will be given back as a model. Now I have also used the optimizer SGD optimizing in order to optimize during the training process. Now this is compiled, and you can see this is the compilation taking place. At the next step is to fit this particular model convolution neural network on the training set. Now you can see this is, we are giving only the training set and the test set initially over here. So not test set, only training set and the training y, that is the target variable what we want to set, that is mentioned over here. And what is the batch size, that is also given. Number of epochs, two, that is minimum I have set over here in order to fasten the procedure. And you can also perform the validation during the training phase. During the validation you can give the what the testing set, the test x values, that is the number of images as well as the test set. So it will reflect upon the whether the training process is taking place or not. And shuffle is also made it as true in order to shuffle the during the training procedure. And this is how you can see the second epoch is taking place. The first one is already finished with a validation error of 0.63 and accuracy of 0.8. So this is very good when you take the smaller data set and training it on the fewer number of samples. And we can also evaluate this particular model with the help of evaluate the given model. So you can take the evaluate method and apply it on the test samples. So these are the test input, and this is the expected outcome. We can print out the accuracy as well as the loss. The loss for this particular test is 0.55, and the accuracy for the test is 0.8. So 0.8 is pretty good, and with the help of only two epochs it has trained up to 0.8 accuracy. So in this one session we have seen how do we build the convolution neural network on the sentiment image data and also perform the prediction. You can also refer the complete code of performing this sentiment analysis in my GitHub. So you can go through this GitHub. The link is provided in the below description, and you can also see that the same Twitter database link is also provided over here. So this will be more useful for you. I hope you enjoyed this particular video. If you have any suggestion or queries, please write to me, Also subscribe to my channel. I'm happy to share many much more videos, and based on your feedback I can also improve my video quality. Thank you everyone for watching this video.